All right, welcome. Today, we're going to go on a really fascinating journey. We're going to see how we can move from just looking at what's already happened to using data to predict and even shape what happens next. This is the leap from prediction to prescription.
You know, this quote just perfectly sets the stage. If your business is only relying on past reports, you're literally driving while looking in the rearview mirror. Sure, it tells you exactly where you've been, but it tells you nothing about the road ahead. To really lead, you have to look forward, through the windshield.
So that's the first big shift we need to make, moving from hindsight to foresight. It's all about adopting what our source material calls the Windshield Mindset. It's a complete change from being reactive to being proactive.
And this is exactly what that mindset is built on. Predictive Analytics is that windshield for your organization. It's not just about seeing what's right in front of you. It's about seeing the sharp curves, the potential roadblocks, and the big hills way up on the horizon. It gives you precious time to actually prepare and make a smart move.
So how in the world does this windshield actually work? Well, a key engine behind it is something called supervised learning. The best way to think about it is like a student who gets to study for a test with the answer key right there. The model chews through tons of old data where the outcome is already known. It learns all the hidden patterns, and then it uses that knowledge to make predictions on brand new data it's never seen before.
Okay, so now that we've got this forward-looking mindset, we can start asking questions. And it turns out there are two fundamentally different types of predictive questions. This is such a critical distinction. Are you trying to figure out how much of something or which one from a list of categories?
And this slide just nails the difference. On the left, you've got regression. Its whole job is to predict a number, a continuous value. Questions like, how much will our sales be next quarter? Or how many calls will the help desk get? The analogy is perfect. It's a thermometer. It gives you a very specific degree, like 72.4. Now, on the right, you have classification. Its job is totally different. It's all about putting something into a specific bucket or category. Is this email spam or not spam? Will this customer leave us or will they stay? This is the traffic right. You get a clear, distinct answer, red, yellow, or green. There is no in between.
So for the next few minutes, let's really focus on mastering classification. And to do that, we're going to dive deep into one of the most intuitive and honestly powerful tools out there for this job, the decision tree.
So what is a decision tree? Well, at its core, it's basically just a flow chart. It's a very clever one, though. It takes all of your data and sorts it down through a series of simple if-then questions based on its attributes until everything is filtered into a final category. What makes it so powerful is that it kind of mimics the way our own brains make decisions.
Now, how the tree gets built is just this beautiful logical process. Let's walk through it. First, the algorithm scans all your data to find the single best attribute that splits it most cleanly. Second, it creates a new branch for every possible value or answer for that attribute. Third, it pushes the data down the correct branches, creating smaller groups. And finally, number 4, and this is the magic right here, it repeats that entire process over and over again on each new subset until it gets to a pure group, where everything in that final little leaf belongs to the exact same category.
But that leads to the million-dollar question, doesn't it? I mean, if you've got dozens of attributes in your data, how does the algorithm possibly know which one is the best one to start with? How does it pick the one question that will bring the most clarity right off the bat?
The answer comes from a really cool concept in information theory called entropy. Basically, entropy is just a mathematical way to measure messiness, the amount of impurity, disorder, or randomness in a dataset. So the algorithm's goal is incredibly simple. At every single step, it picks the attribute that reduces entropy the most, the one that creates the cleanest, most organized split.
And if entropy sounds a little abstract, this analogy makes it so easy to understand. Imagine you have 2 drawers. The one on the left has low entropy. It's perfectly sorted. It only contains white socks. It is perfectly pure. Reaching in to make a decision is effortless. You know exactly what you're going to get. Now, the drawer on the right, that's high entropy. It is a complete disaster. It's full of socks, some batteries, junk mail. It's totally impure and disordered. Reaching in is a gamble. The outcome is uncertain. The decision tree is always trying to create drawers that look like the one on the left.
And in the sample data that was used to build a model for this idea became crystal clear. There was one attribute, the outlook, and one of its values was overcast. And it turned out that every single time the outlook was overcast, the outcome was exactly the same. That created a perfectly pure split, just like our drawer of white socks. And because of that perfect purity, its entropy score was exactly 0.
But here's the catch. This relentless drive for purity can actually be dangerous. You can build a decision tree that's so incredibly detailed and complex that it perfectly explains every single quirky data point from your past. This is a huge problem called overfitting, and the analogy here is just fantastic. It's like an over-tailored suit. It fits the mannequin of your historical data perfectly, but it's completely useless in the real world when you need to actually move.
So, how do we fix this? The solution is an elegant process called pruning. Seriously, just like a gardener trims a bush to keep it healthy and strong, we prune our decision tree. We strategically snip off those tiny, less important branches that were basically just memorizing the noise in our data. This makes the model simpler, more robust, and way more likely to work on new data out in the real world. Okay, so let's shift gears and move to our final section, where everything we've talked about really comes together. We went from the rearview mirror to the windshield. We learned how to predict what's coming. Now, we're ready for the final frontier, using that knowledge to prescribe the absolute best course of action.
And this question just cuts right to the chase. It is awesome that your predictive model, your windshield, tells you there's a 90% chance of a huge traffic jam on your commute. That's great information. But that information is only useful if it helps you make a better decision. So, yeah, now what?
And here is the answer. Prescriptive Analytics is the magic inside your GPS. It doesn't just warn you about the traffic jam, it instantly analyzes all the other possible routes and recommends the optimal one to save you time. See the difference? It's not just about seeing the future, it's about actively finding the best possible path through that future.
So how does it actually calculate that best path? Well, pretty much every optimization problem boils down to 3 core building blocks. First, you have the objective. What is the one single thing you're trying to achieve? Usually it's maximizing something good, like profit, or minimizing something bad, like cost. Second, the decision variables. What are the levers you can actually pull, the knobs you can turn, the choices you can make? And third, you have the constraints. What are the real-world rules and limits that you absolutely cannot break? Think budgets, deadlines, or regulations.
This table makes it super concrete. Let's say you're a project manager. Your objective is clear: minimize total labor costs. Your decision variables are the number of hours you assign to each person on your team. But you operate within real-world constraints. The project has to get done, nobody can work more than 40 hours a week, and you have to stay under budget. A prescriptive model takes all these pieces of the puzzle and solves for that perfect sweet spot, the exact staffing plan that meets every single rule at the lowest possible cost.
And that really brings us to the core philosophy of this entire journey. Real success in analytics isn't about who can build the most complicated mathematical model. It's about achieving what the source calls radical clarity. The ultimate goal is and always should be the same: to turn that messy, raw data from the past into tangible strategic value for the future.
So we'll end with this. I want you to turn this question back on yourself. As you think about your own team, your own company, are you spending most of your time and energy just polishing the rearview mirror, endlessly reporting on what's already done? Or are you truly looking through the windshield, using data not just to see what's coming, but to find the absolute best way to get there?